Hello everyone and welcome back to Up 360 Circuits, your go-to channel for electronics tutorial, embedded systems and practical IoT projects. In today's project, we will be exploring the MCU-055 BNO055 9DOF orientation sensor module, and we are going to be using the sensor itself, an Arduino Uno microcontroller and some jumper wires. The sensor is a powerful 9-axis inertial measurement unit, or IMU, capable of measuring acceleration, rotational motion, magnetic field strength, and device orientation. The sensor is widely used in robotics, drones, self-balancing robots, and tracking systems. It combines multiple sensors with an onboard processor that performs sensor fusion internally. However, many users encounter a common problem when using the MCU-055 sensor. Even after wiring the module correctly and uploading an example code, the sensor is often not detected over the I2C interface. In this video, we will briefly examine the sensor, explain how it works, demonstrate the cause of this communication problem, and show the simple hardware fix. We would also verify that the sensor is working correctly. Let us begin with a brief overview of the MCU-055 sensor. The sensor is a 9 degrees of freedom or a 9DOF inertial measurement unit. It combines a 3-axis accelerometer, a 3-axis gyroscope, and a 3-axis magnetometer, which means it measures calibrations in X, Y, and Z. That is what the 3-axis means. In addition to these sensing elements, the sensor also contains an onboard 32-bit microcontroller that combines data from the three sensors using Bosch Sensor Fusion algorithm. Instead of requiring the Arduino to process raw accelerometer, gyroscope, and magnetometer data separately, the sensor performs these calculations internally and provides processed orientation and motion information directly. Now, some of its key features include the 9 degree of freedom motion sensing, its built-in sensor fusion, its high measurement accuracy, its I2C and UART communication support, its low power consumption, and of course, it's a compact module to use. The sensor is also commonly used in projects requiring accurate motion sensing and orientation tracking. Now, although the sensor is an excellent sensor, many users experience communication problems when using the MCU-055 sensor. After wiring the sensor correctly and uploading the example sketch, the Arduino reports that no I2C device is detected. Even an I2C scanner often fails to detect the module. Fortunately, this problem is usually not caused by faulty wiring or a defective sensor. This happens because the sensor supports multiple communication interfaces, including I2C and UART. The communication mode is selected using two configuration pins labeled SO and S1. Now, on many MCU-055 sensors, these pins are left unconfigured during manufacturing, and as a result, the sensor does not start in the I2C mode when powered on, preventing its communication with the Arduino. Now, how can this be solved? Fortunately, the solution is quick and straightforward. On the sensor, there are pins labeled SO and S1, and you can also see ground and positive. So, to configure the sensor for I2C communication, both the SO and S1 should be connected to ground by creating small solder bridges. This takes care of the configuration and the communication issue. So once both pins are connected to ground, the sensor will start in I2C mode whenever it is powered on. Alright, so I will show you now how the sensor is connected. On the sensor we have about 8 pins, but we would only be using the VCC, the ground, the ATX, which is also the SDA. If you turn it backward, you see SDA, and then the LRX, which is also the SCL, and the I2C. So it's very easy to connect. Just take your jumper wires, connect the wire to VCC, connect it to 3.3 on your Arduino. Then we're going to have to jump our ground out. Why? Because both the I2C and the ground on the sensor need to be connected to a common ground from the Arduino. So just jump that out. Yeah. Then another wire connected to ground, and then the ground on the breadboard like that. And next up, the ATX, which I also said is the SDA, so that will be connected to A4 on your Arduino. A4. Then the LRX, which is the SCL, to A5, and then the I2C pin to ground. Alright, so now we'll test the sensor first without soldering the SO and S1 pins to ground. We'll be using the I2C scanner example to see if we can read its I2C address. Just plug your Arduino into your computer and run the sketch. And upload the sketch. Yes, as you can see, our serial monitor begins to display that no I2C device is found, which is expected because our SO and S1 pins are not yet soldered to ground. So now I'll disconnect my Arduino, solder the pins to ground, and then rerun the I2C sketch. You have to be really careful when soldering your pins to ensure that they do not bleed with more than the ground. Yeah, and now that it is soldered, I'll reconnect my sensor and then rerun the I2C scanner sketch. Okay, now that our sensor is connected, so just connect the Arduino back to your system, rerun your sketch, and as you can see, our serial monitor begins to display that an I2C device is found at an address 0x28. I'm also going to run a simple example from the Adafruit library, just the raw data, so that we can observe how the sensor gets the gyroscope, the accelerometer, and the magnetometer reading. So I'm just going to upload this sketch. Now that it's done uploading, I'll toggle my senior monitor. Don't forget to change your baud rate from 9600 to 115 200. Yeah. And now you can see that readings are being displayed on our serial monitor, and as I move the sensor, our readings change. The X, Y, and Z readings change as the sensor is being moved, and so does the gyroscope and accelerometer. In this project, we successfully explored the MCU-055 BNO055 9DOF orientation sensor module and resolved one of the most common issues affecting its I2C communication. We were able to understand how the sensor works, learn its onboard sensor fusion simplifying motion sensing, identify the cause of the I2C communication problem, configure the SO and S1 pins correctly, successfully communicate with the Arduino, verify the sensor's operation through practical testing, and once it was properly configured, once it is properly configured, the sensor is an excellent IMU sensor for application motion sensing, orientation tracking, and real-time position estimation. If you found this project helpful, don't forget to like, share, and subscribe. And for quality electronic components, check out of 360 circuits. Thank you for watching, and I'll see you in the next project.